So in our work, we present a method that distributes a heterogeneous swarm of robots among a set of tasks. The core of our work is really the topic of heterogeneity or diversity. And the idea here is that by solving a specific problem with a heterogeneous swarm of robots, we're able to understand what it actually takes to build heterogeneous systems. So the reason that we're interested in heterogeneity and diversity is that these are concepts that have been incredibly successful in biological systems. But we haven't really cracked the case of diversity for engineered systems, and that is really what we're trying to do here. So what's special about our approach is that we encode diversity into the way we represent our system. And this allows us to develop a method that is special or specific to heterogeneous systems. And it turns out that it really does perform much better than methods that are normally developed for homogeneous systems. So the other special thing about our method is that we encode diversity at a global macroscopic level. And this leads to controllers at the microscopic agent level that perform optimally in a stochastic sense and lead the system to converge to the desired outcome.
So in biology, a fundamental metric that is often used is this notion of fitness. The fitness of a species, right, really wants to capture the ability of the current generation to propagate the best genes onto the next generation. A fundamental challenge in terms of engineering heterogeneous and diverse systems is that this notion of fitness does not really apply. And so a big question is, what are the correct performance metrics we need to use in order to assess the performance of these heterogeneous engineered systems?
So I think that the first thing that we need to do is to really understand what applications and what problems can benefit most from a deeper understanding of diversity in engineered systems. Once we know what those are, we can think about the methods, analytical foundations that will lead us to create the techniques that allow us to get better performance.
A research goal for this project is about trying to address the fundamental scientific as well as technological challenges in our ability to lay down a general mathematical as well as modeling framework that will allow us to talk about the design optimization of engineered heterogeneous systems for all kinds of applications.